So, hello everyone, this is experiment number 3. So, in this experiment, we are going to perform linear regression, multilinear regression, and logistic regressions. These are the three important regressions which we will be doing in the part of experiment 3. So, let's start one by one, and I'll be explaining you how each of this code works line by line and what inference we can get from this particular experiment. So, proceeding to question number 1. Before that, I have already implemented all the necessary libraries which are here, which is pandas, numpy, and matplotlib. So matplotlib is for plotting all the graphs, and numpy is for handling all numpy and pandas is for handling all the data here. So now the first question talks about reading the CSV data into the pandas data frame object. So here we are doing nothing but just reading the CSV file, which is iris.regression.csv. So to make sure that my data set has been loaded properly, I'm using df.head and checking whether it has worked properly or not. That is all about it. So moving to question number 2, we are performing actually some sort of data cleaning, which is perform a data cleaning to find out the missing values and impute the same value with mean. So here we are using the function called df.isnull.sum. So with this, we will be able to find out the missing values and perform data cleaning to it. So the inference which we can get here is that some values are missing here. So sepal length cm has 5 missing values. So we replace those missing values with the mean of that whole column. For example, if the column value has 5.1, 4.9, not available, and 5.0, so the mean of these four data is 5.0. Therefore, NaN becomes 5.0. This is the inference which we get from here. So the next question here is choose independent variables x and dependent variable y from the given dataset. So here the independent variable is sepal length centimeter, and the dependent variable is sepal width centimeter. So I am printing the length of x and printing the value of n. I have stored length of x, which is the independent variable, in n, and printed that n value. So we get here 150. That's the meaning. So the meaning is that we are predicting sepal width from sepal length. That's the inference which we get here. So the next question is compute B0 and B1 using the formula and display the same. So before that, we need to know the formula. So the linear regression equation is y is equal to b0 plus b1x. So here b0 means intercept and b1 means slope. And the mean calculation, we perform mean calculation. These two codes, x bar equal to np dot mean of x and np dot mean of y. So these two values are the mean calculation values. Then we have the formula just by substituting uh, the value of b0, which is you're finding b1 using b0. So y becomes when y is b0 plus b1x, so b1 becomes y minus b0 divided by x. That's the formula, and that's the formula which you're applying. Or dcan is the formula for b1 is sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar the whole square. So this is the formula. So with this formula, we are able to find b0 and b1. So we get b0 as 3.419 and b1 as minus 0.06. So that's the inference which we get from here. So the final equation becomes y is equal to 3.41 minus 0.062 into x. That's the one. So the next question here is formulate the equation for y pred and calculate y prediction. It's very simple. Y prediction is equal to b0 plus b1x. We just substitute the values and I only find the first 5 values, the first 5 predicted values of this. That's it. So we have the next question, which is calculate the SSE, sum of squared error value. So the formula is summation of y minus y predicted the whole square. I have applied this formula here using numpy and found out SSE. Similarly, we go for RMSE. So RMSE formula is under root of SSE by n. I just take the previous value from SSE and divide it by length of y. With that I get RMSE. So RMSE means uh, under root of SSC divided by n, which means that if the value of RMSE is small, the model is better. That's the inference which we get. So moving on to question number 8, the value of R score. They are asking us to calculate coefficient of determination, just R square. So here, there are two methods in which you can find. One is 1 minus SSC by SST, or we can find the value of SST by summation of y minus y bar the whole square. So I have applied both the formulas here because I need first SST. So SST formula is y minus y bar the whole square, summation of y minus y bar the whole square, and R square is equal to 1 minus SSC by SST. With this, I'll be able to find out R square. So here, I found out R square is 0.0138. So, which means that only 1.3% variation is explained here, which means the model is very weak. The dataset which we have here, the model is very, very weak. So the next question is plot regression line along with the given data points. It's very simple. I just use a scatter plot and I take the value of x comma y, and then I also plot x comma y prediction for sepal length and sepal width, and that gives you linear regression. So this is the graph for that. So yeah, next, predict the new value for any given value of x. Predict y. So it's very simple. I have taken a random value x equal to 6 and I have substituted in the formula, and I get y is equal to 3.004. So yes, this is all about linear regression, which means one variable with the other variable, predicting one variable with the other variable. Whereas when it comes to multiple linear regressions, we use two or more independent variables. That's the meaning of it. So here we are going to use for multilinear regression uh, x1 as sepal length and x2 as petal length. So as you can see, first questions always is about reading the data set. I have read the data set here. Nothing much is needed to be explained here. So the second one, as usual, again, I need to perform missing values, find out the missing values, and perform data cleaning. I have done that using the function called df.isNull.sum, which means if any column has missing values, I take the average of the whole column and add in the places where it is not available, fill that with the average of the missing columns. So as you can see, before cleaning it is this, and after cleaning it is this. So the third question is about choose independent variables x1 and y1. I have chosen it. I have combined it. So yeah, the next question is compute the y-intercept and independent variable correlation coefficient using the formula and display the same. So this is a very important concept. Here, the formula is beta is equal to x transpose into x the whole inverse multiplied by x transpose into y. So that particular piece of code is this equation, normal equation. So with that equation, first what I do, I convert this into numpy, it's very important, and after that I add a bias column. After adding the bias column, I use it in the normal equation and flatten it to get the coefficient. With that, I get B0, B1 and B2. So here's the values for that. Moving further for question number 5, formulate the equation of y prediction and calculate the y prediction. So I have used the y prediction formula as B0 plus B1x plus B2x. So with this, I found out the first 5 predicted values. And here are the values for that. I can calculate as much as I want, but for as of now, I have only taken first 5 predicted values. Okay, moving further, find out sum of squared errors. So as usual, I have used numpy for this, summation of y minus y prediction the whole square, and that gives you the formula and gives you the answer as 5929.320. And moving further, we are asked to find out RMSE, root mean squared error. So I have again used the numpy dot squared SSE by length of y. That will give you RMSE. And just like how we discussed before, coefficient of determination r square is equal to 1 minus SSC by SST. We have to find SST because we didn't find SST in the previous question and we have found only SSC. So to find r square, I need both SSC and SSE. So I find out first SST and then substitute the value, and I get the value is r square equal to minus 210, which means, again, let me give you two observations here. The first observation is that SSE, which is very large, and high RMSE, we got around somewhere around 6 point something. Yeah. So this means that the model is really a very bad model fit. And again, negative R square means that the model can perform very worse, which means that it can't predict properly. So for multilinear regression, it's a very worst kind of prediction which you can perform, which is not really helpful for us. So that is the information we get here. So we go on for the next question, the next topic, which is logistic regression. So this is a categorical classification rather than a numerical classification. So here, logistic regression helps in various ways. So I'll be explaining you with the help of these questions here. So as usual, the first question is to read the data. I have read it. The second question is asked to perform the necessary data imputation, which means wherever there's a missing values, I find out that and use the mean value and put it there. Yes, and before that, we need to use label encoding. Why? Because machine learning works only with numerical data, not with text or strings. So for that, I'll be using label encoding. Label encoder helps in solving this issue. So I have done that and it classified either 0 or 1. It's somewhat like a binary classifier. And the next question here is choosing the independent and the dependent variables. I have chosen the independent variables and the dependent variable is species. Yes, now comes the important question. Sigmoid function. This sigmoid function is like a probability predictor function. Why we use this? It converts the values into the range between the probability of 0 and 1. The formula we use here is A is equal to 1 by 1 plus e raised to minus z. I have used the same implementation here. This. After that, we need to find the cost function. The cost function formula is minus 1 by m summation of y into log a plus 1 minus y into log of 1 minus a. Here, we are using this cost function to minimize the gradient distance. So we have minimized this using the gradient distance. The gradient distance means the cost function. Here we need to update the weight. So before that, you can see something called, yeah, we have updated the weight. After that, we do it for 1000 iterations. So why we do it for 1000 iterations? Because the model can learn again and again more perfectly, and we find the accuracy of it. So yeah, we have trained the model. This whole piece of code train the model. After that, we found out that the accuracy, we'll talk about accuracy later. So when you see the graph, the cost, we have performed almost like 1000 iterations and we have used a graph between iterations and cost. Yes, it is iterations. The x-axis is iterations and the y-axis is cost. So for this, the graph goes linearly downwards. That is the inference we get from here. And as you're asked to find the accuracy after using the sigmoid function formula is 33% only, which means that the very most important inference we can get here is the whole model is performing very poor because it has only three classes, but the logistic model is binary. So that is why the overall model is a very poor model, a bad model fit. This is the overall conclusion which we can get from this experiment. Thank you and have a nice day.